Welcome back. Today we're going to talk about parabolas, and it's going to be similar to our discussion of lines. Namely, we're going to talk about what the equation of a parabola looks like, and it's something that's not too different from y equals mx plus b. We're going to talk about what the equation tells you about the graph, and then we'll do a couple examples, and we'll be in good shape. Okay. So first of all, I should tell you, the equation of a parabola that we're going to talk about is always going to look like y equals ax squared plus bx plus c. And there's two pieces of very important information that you can glean from looking at y equals ax squared plus bx plus c. Okay. So the first is whether the parabola points up, so this is the kind of parabola that I'm going to say points up, or down. And namely, the thing that tells you that is the a. And so it points up if a is bigger than 0, and it points down if a is less than 0. Okay. So that is the first piece of information that you can glean from looking at a parabola written like this right away. Note if a is 0, it's not a parabola. It's a line. Okay. That's because if a is 0, you get 0x squared, so you can just drop that, and then you just get y is bx plus c, but that's just the y equals mx plus b with different names. The second piece of information that you can read off of this equation is you can find the location of the vertex. And the vertex is this point, whether the parabola happens to point up or point down, it's this point where the function changes direction. In this case, it sort of swaps from getting bigger to getting smaller, or in this case, getting smaller to getting bigger. You could think of it as sort of the parabola's nose or whatever, if you like that better. And so the x-coordinate of the vertex of a parabola is always given by negative b over 2a. So negative that term in front of the x divided by 2 times that term in front of the x squared. And so now, if I give you a parabola, I can ask you a whole bunch of questions about it. So I can say something like, for the parabola y equals x plus 2 times x minus 4, let's find all the x and y intercepts, and the vertex. Okay, so if we do that, well, let's go ahead and find, let's say, x-intercepts first. So I find x-intercepts by looking where the output is 0. That is where y is 0. So I'll get 0 is x plus 2 times x minus 4. And I need to solve this equation. And so I can see this is going to give me an x is minus 2. This is going to make an x is 4, plus 4. Again, this is because it's equal to 0 that I can do this. So there's two x-intercepts, namely minus 2, 0, and 4, 0. For the y-intercept, remember the y-intercept always corresponds to the output that you get from the input 0. So namely, it's telling you when x is 0. And so you'll get y is plus 2 times minus 4, which is to say minus 8. And so that is to say that the y-intercept is at 0, comma, minus 8. Okay, and both of these are questions I could have asked you last section. But now the new part here is we can ask about the vertex. Namely, when I go to find the vertex, I need to actually write this out the way that I wrote it out up here. So that is, I need to write it as x squared minus 2x minus 8. And so the x-coordinate of the vertex is going to be at negative b, which is negative 2, over 2a. A is just 1. It's the coefficient from the x squared. Okay, and so the x-coordinate of the vertex is in fact 1. which means the vertex looks like 1, comma, something. And how do I go ahead and find the something? I find the something by knowing that this is on the graph of y equals x squared minus 2x minus 8, and so I can just plug the input 1 into this and find the output. I will sneak that in up here. So that will tell me that y is 1 squared minus 2 times 1 minus 8. And so that will be minus 9. And so that is the coordinates of the vertex. You can take a moment to think about this. Does this parabola point up or down? This parabola points up because, again, the a is 1 and 1 is more than 0. Okay, let's do the same type of question. Namely, let's look for the x-intercepts, the y-intercepts, and the vertex of this parabola. Before I can really do anything productive, I'm going to have to FOIL out this mess anyway, so let me start by doing that. And so I'm asked to do 3 things here. Find the x-intercepts, find the y-intercepts, and find the vertex. When I go to find the x-intercept, I know what I'm supposed to do. I'm supposed to set 0 is equal to minus 4x squared minus 8x minus 10. I notice I can divide everything through by 2, or in fact by minus 2, so that'll give me 2x squared plus 4x plus 5 equals 0. And then I'm trying to factor this, and I don't really see how to factor this. So I'm going to press pause on finding the x-intercept, and then I'm going to jump ahead and do the y-intercept. Okay. So I'll put a question mark here to make sure we come back to this. The y-intercept, again, corresponds to the output that you get from the input 0. So that will be y is equal to minus 4 times 0 squared minus 8 times 0 minus 10, which is just minus 10. And so my y-intercept here is going to work out to be 0, comma, minus 10. By the way, it's worth mentioning, when you look at this ax squared plus bx plus c, you can also interpret this plus c here as really being the y-intercept. What about the vertex, though? Well, the way I find the vertex is, again, that the x-coordinate of the vertex is at negative b, which will be plus 8, divided by, and then 2a, so that'll be 2 times minus 4. And so that will work out, in fact, to be minus 1. And so my vertex is at minus 1, comma, and then I need to plug in minus 1 here. So when I plug in minus 1, I get y is minus 4 times minus 1 squared, minus 8 times minus 1, minus 10. So this is minus 4 plus 8 is plus 4, minus 10 is minus 6. And that is my vertex. Okay. And now I hoped that by the time I got here, I would have some insight about what's happening with the x-intercepts. And actually, if I think about this in terms of a graph, I can actually think about it. So the vertex here is at minus 1, minus 6, so it's something like that. In which way does the parabola point? Well, it points down, right, because of that minus there. And so if I imagine what that's going to look like, it's going to look like that. And so what does that actually mean about the x-intercepts? Well, this parabola starts below the x-axis, and then it points down. And so, in fact, this parabola actually has no x-intercepts. And so, roughly speaking, what I'm telling you is that half the time, if you look at a parabola, it's going to have no x-intercepts because it's going to point away from the x-axis instead of towards it. And the way you can know for certain if that's happened or not is to look at where the vertex is and then look at the direction that the parabola points. And so sometimes when you ask about x-intercepts of a parabola, you're going to find two of them. That's going to happen if you point from the vertex towards the x-axis, as happened in our last example. Or there'll be none of them if the parabola points from the vertex away from the x-axis. And on very, very rare occasions, you'll actually find a parabola with one x-intercept, and that'll happen when the vertex actually is on the x-axis itself. And so, if you want to imagine what these three things look like, I can draw you pictures. Here's a parabola with two x-intercepts. Here's a parabola with no x-intercepts. And then here's a parabola with exactly one x-intercept. And again, you can decide all of these by the two pieces of information: where is the vertex, and which direction does it point? All right, we'll wrap up there for now. We'll pick up next time talking about functions that have some sort of connection to the real world, so things like heights of rockets and other variations thereof. But for now, I'll see you next time.